Hi, I'm Marty Mendenhall, a strategic energy management coach. In today's video, we look into a puzzling airflow problem. Most of the time, the buildings seem to operate just fine, but occasionally, doors wouldn't stay open. Or worse, outside air seemed to rush into the building, and every once in a while, the exhaust fans showed irregular behavior. The system said everything was normal, when clearly something wasn't right. To find the ghost in this building, we had to dig a little bit deeper. The building's exhaust fan didn't always behave the same way. Sometimes it slowed down unexpectedly. This triggered problems throughout the facility. Most noticeably, the exterior doors wouldn't close all the way. In some cases, they remained open long enough to miss the automatic security lock for the evening, creating both comfort issues and safety concerns. At other times, the exhaust fan would speed up inexplicably, even when there was no clear reason. The doors stayed shut, but cold air seeped in through gaps around doors and windows, leading to comfort complaints from building occupants. Meanwhile, the facility manager noticed unusual spikes in heating and cooling costs, with no clear connection to outdoor temperatures. The system was designed to maintain a positive 0.03 inches of pressure, regulated by a differential pressure sensor. One port measured pressure in the lobby, and the other on the roof, to compare outdoor conditions. On the building automation system, or BAS, everything appeared normal, but the building was telling a different story. The team checked everything. The control wiring was correct and terminated properly. There was no interference from nearby high-voltage wires, and both the indoor and outdoor pressure ports were clear, correctly installed, and leak-free. The differential pressure sensor was fully calibrated and piped correctly. Even the VFD, variable frequency drive ramp settings, were solid. Transitions were smooth, no hunting, and no signs of lag in the control response. With all the hardware working as intended, we had to ask the bigger question. If everything looked right, why wasn't the building pressure staying slightly positive? The breakthrough came with one simple question. Where exactly was the indoor pressure being measured? A closer investigation revealed that the differential pressure sensor's indoor port was located in the main entry, right next to the lobby doors. That made it vulnerable to wind. On cold, windy days, especially when the wind came from the east, something strange would happen. As the lobby doors opened, the wind would rush in and hit the differential pressure sensor's probe. The continuous flow of outside air caused the sensor to spike high. In response, the BAS system thought the building was overpressurized, so it ramped up the exhaust fan to bring the pressure back down. The result? Completely erratic pressure control. Fluctuations in building pressure led to opposite problems. When the building pressure rose too high, the lobby doors were forced open from too much positive building pressure. Conversely, cold air could rush in through the building envelope and cause the building to dip into negative pressure, especially across the first floor. The solution? Move the sensor to a location unaffected by wind, somewhere with stable interior conditions. It wasn't a quick fix. The facility manager took some time to find a better spot, eventually relocating the sensor to a hallway outside the first floor restrooms. Still central to the building, but far enough away from the lobby doors to avoid wind interference. After that change, things quickly stabilized. The exterior doors began closing properly, and fan speeds returned to normal. For the first time, the BAS pressure trends actually reflected what was happening during real-time building pressure conditions. When your building pressure control isn't working, it's tempting to blame the hardware. But when sensors send the wrong signals, even a well-tuned system can make the wrong decisions. If your BAS says everything's fine, but your building disagrees, be sure to check your sensor location. Thank you for watching this Energy Trust of Oregon video. Check out the other energy-saving videos in this series by using the QR code.